In 2016, a risk analyst at a financial services company noticed something strange in the transaction database. A corporate client called Smith, Johnson & Partners had been split across two rows, Smith on one row, Johnson & Partners on the next. The transaction amounts were wrong. The counterparty was wrong. The risk model had been calculating exposure for that client incorrectly for 7 months. Nobody had noticed because no error was ever thrown. The pipeline had read the CSV file correctly, according to what CSV files actually are. A comma inside the company name looked identical to a comma between columns. The parser did exactly what it was designed to do. It treated every comma as a delimiter. The data was split. The record was broken. The pipeline reported success. This is the fundamental problem with CSV files. They look simple. They are not safe. CSV stands for comma-separated values. It has no official standard, no enforced specification, no built-in way to declare what it contains or how it should be read. It is a set of conventions that different systems implement differently and that breaks in a completely different way depending on who created the file and who is trying to read it. 3 failure modes account for the vast majority of CSV corruption in production systems. The first is the delimiter problem. A CSV file separates values with commas. Business data contains commas constantly. Company names, addresses, descriptions, free text fields. When a value contains a comma, the convention is to wrap it in double quotes. Smith, Johnson & Partners becomes a single quoted value. The parser knows the comma is inside the value, not between values. But this only works if the system that created the file followed the convention. Many don't. User-entered data arrives after the format was decided. Legacy systems were never updated to handle quoting. A third-party provider exports files from software that doesn't quote values containing commas. The result is a file that looks correct in a text editor and breaks silently in a parser. No error. A corrupted record. A pipeline that reports success while loading wrong data into your warehouse. The second failure mode is encoding. Every text file is stored as bytes. To read those bytes as characters, you need to know the encoding, the system that maps byte values to characters. The 2 encodings you will encounter most often are UTF-8 and Windows 1252. For standard English text, they are identical. The moment someone enters an accented character, a name like Jose, a currency like Euro, a company with a nun, they diverge. Excel, by default, saves CSV files in Windows 1252. Python, by default, reads CSV files as UTF-8. When a Python pipeline reads an Excel-generated CSV without specifying the encoding, accented characters become garbled symbols. E becomes A, nun becomes AN, or worse, the parser throws an encoding error and stops entirely, with a message like codec can't decode byte 0x92 in position 847 in a file with 200,000 rows. The morning processing window passes, the data is a day late, all because a name had an accent in it. The third failure mode is Excel's auto-conversion, and this one is uniquely destructive because it is permanent. When you open a CSV file in Excel, Excel reads every value and decides what type it is. A value that looks like a date becomes a date. A value that looks like a number loses its leading zeros. A long numeric ID gets converted to scientific notation and loses precision beyond 15 digits. This would be manageable if Excel left the original file alone. It doesn't. When you save the file, the conversions are baked in. The original values are gone. The most documented example of this comes from genomics research. The gene sept2, septin2, looks to Excel like September 2nd. Excel converts it to 2sep. The researcher saves the file. The gene name no longer exists anywhere in the dataset. A 2016 study in genome biology found that roughly 1/5 of published genetics papers with supplementary data files contained gene names corrupted by Excel's auto-conversion. 1/5 published. Peer-reviewed. Silent corruption that passed through the entire research and publication process without anyone noticing. The consequences were significant enough that in 2020, the scientific community changed the official names of affected genes specifically to prevent Excel from converting them. SEPT2 became SEPTIN2, the format 1. The data adapted to the tool. So what does a safe CSV pipeline actually require? 3 things above everything else. First, always specify the encoding explicitly. Never let the parser guess. Agree with every data provider in advance that files will be UTF-8. For legacy systems that cannot produce UTF-8, detect the encoding before reading and declare it in every read call. One line of code eliminates an entire class of failure. Second, validate the file before processing it. Count delimiters per row. If any row has more delimiters than the header, something inside a value is being treated as a delimiter. Stop the pipeline, alert, investigate. Do not load corrupted data into the warehouse and discover the problem 3 months later. Third, never use Excel to open production CSV files if those files will be saved again. Excel is for viewing. If you need to inspect a file, use a text editor. If a file has already been through Excel, treat any codes with leading zeros, long numeric IDs, and values that look like dates as potentially corrupted, and verify them before processing. CSV's strength is its universality. Every system in the world can produce one. Every system in the world can read one. That universality comes at a cost. The format carries almost no self-describing information. It doesn't know its own encoding. It doesn't know its delimiter convention. It doesn't know that SEPT2 is a gene name and not a date. All of that knowledge has to exist outside the file, in the agreement between sender and receiver, in the pipeline that reads with explicit validated assumptions, in the tests that catch a broken file before it reaches production. When that external knowledge is absent, the CSV file does exactly what it was designed to do. It delivers bytes. What those bytes mean is your responsibility to specify before the pipeline runs, not your analyst's problem to untangle 7 months after the data went wrong.